So I just want to hit a couple things I didn't get to hit in class. So when you see a rational function, when I say rational, I mean it's a fraction, and so it causes some problems, and we're looking for vertical asymptotes specifically. Really, maybe the first thing you might want to do is just go ahead and factor it. So down low, we have, that's difference of squares there, so x plus 2 times x minus 2. And up top, does that factor? Let's see. Is that difference of squares? Well, no, I don't think so. 3x squared minus 4. It doesn't really factor. So I'm just going to leave it as 3x squared minus 4. Nothing cancels. So I do have some things I can gather from this, which is right here, this is going to cause a vertical asymptote. And right here, this is going to cause a vertical asymptote. So when those are equal to 0, so in this case, when x is equal to negative 2, and when x is equal to 2, we're going to have vertical asymptotes. Looking at the end behavior, you can see the first term is 3x squared. In the denominator, the first term would be 2 times x, which is 2x squared. And so just looking at the coefficients of those two, you can see that the horizontal asymptote is at 3/2, or actually I should say the equation y equals 3/2. So you make your graph -2, something like this. Okay, so let's see, we've got x is -2, got a verted dotted line there, and x equals 2. Whoops. Okay. There's about 2 vertical asymptotes, so it's possible to have 2 vertical asymptotes, and then at 1.5, somewhere around here, I've got my horizontal. That was really bad. Okay, try to get that straight. That's a little rough there. Okay, so you're getting the idea. Now I'm going to try to start graphing my graph. So I like to figure out the where the zeros are, so I can plug in x is 0 to find the y-intercept. If I plug in x is 0, I get -4 over 0 minus 4 is -4. 2 times -4 is -8, which is positive 1/2. So somewhere right in here is my y-intercept. I want to find my x-intercept, so I make y equal to 0. The denominator goes away because you multiply by that. 0 times anything is that. So I'm just basically solving this equation. So I get something like 4 equals 3x squared divided by 3 divided by 3. And take square root of both sides. Don't forget plus or minus. So I get plus x is equal to plus or minus 4/3. So let's see, square root, that's really 1 point something. So I'm just going to say it's 1 point something. We could always look it up in the calculator if we needed a more exact value there. So somewhere positive 1 point something and negative 1 point something, somewhere around there. And you can hopefully get a pretty good idea of what happens with this graph. See, in the middle it either does this or this, and looking at the intercepts, you can definitely tell that it has kind of a U shape there. Looks something like that. Off to the right here, I know it doesn't look like this. This is something we mentioned in class. I want to make sure you're getting it. You would have to cross the x-axis. The only 2 spots it crosses the x-axis are there and there. So my graph has to be up in this quadrant when x is bigger than 2. When x is smaller than 2, I have to have a graph either here or here. And if it was here, you can see it would cross the x-axis. It can't be there, so it's got to be up here. And so my graph looks something like that. Now let's go to our next one. And this is where I really want you to see the hole. So I wanted you to see one with 2 vertical asymptotes. I also want you to see one with a hole. So something interesting is going to happen on this one. And it has to do because when you start looking at this, you can identify the vertical asymptote. So you can see that there's a vertical asymptote at x equals 3. And normally you would think there's a vertical asymptote here, but watch what happens. X plus 1 cancels. So when that happens, instead of causing a vertical asymptote, it causes a hole at x equals -1. I'm just going to kind of put that in my back pocket. Let's just kind of remember that. Towards the end of the problem, we'll deal with that. I'm going to pretend like that's canceled now and just deal with this as my function now. So I'm going to graph this, basically. So let's go ahead and graph this. We get vertical asymptote at 3. So I'm going to draw a vertical asymptote at 3. X equals 3. There's my beautiful asymptote. The coefficients are the same, so I look at the degree is the same, so the coefficients are 1 over 1. So at y equals 1, I have a horizontal asymptote. That kind of split this graph into 4 parts there. So let's find the x and y intercept. Plug in x is 0, I get 2 over -3, so I get y equals -2/3, somewhere right down here. If I plug in y is 0, x plus 2 over x minus 3. The denominator goes away, multiplied by 0. Solve this, you get x equals -2. So right over here, that makes sense. In the context of this problem, I either go here or here. Since the intercepts are here, I'm going to go kind of like that. It's going to hug the asymptotes. And over here, I know it doesn't do this because it would have to cross the x-axis. It doesn't. The only spot it crosses the x-axis is here. So my right side of the graph would look something like that when x is bigger than 3. Now there's one last thing I need you to deal with, which is this, a hole at -1. So somewhere in here, I'm going to have a hole. I can find the exact location of the hole, -1 comma something, by plugging -1 into the function after I've canceled out. That's kind of important there. -1 plus 2 is 1. 1 over -1 minus 3 is -4. So I have -1, -1/4. That's my point. So somewhere, let's see, -1, -1/4, somewhere right around. Let me try to fix this here. So there's the axis there, and somewhere right in there, there's a little hole in the graph. So use direct graph a little open circle, approximately -1, -1/4. Somewhere in there is where my hole is, and so your graph will look just like your other graph. Over here, as far as the method, there's just one extra step at the end with the hole. So after you cancel, you can plug that value back in towards the end and then just draw your circle. Let's just kind of look and see how accurate our graphs are. I think I actually did these on the calculator. Let's see what they look like. So here is the actual graph compared to our sketch. Here's the actual graph compared to our sketch. It's not bad. It's pretty good. Oh, did I plug in the wrong value? Oh, this is wrong, isn't it? It should be, sorry, had that wrong. That's not the right point. It's somewhere right in there. That should be closed. Plugged in +1 for some reason. The hole is definitely at -1 because -1 plus 1 is 0. It's what value makes that factor equal to 0. Okay, that's your lesson. I wanted you to see 2 vertical asymptotes, and I also wanted you to see what a hole looks like. And don't forget to factor first. So if you run across problems and they're not factored, they most likely are. But here you can see that one's not factored and so forth, and so you'd want to factor first. Thank you.